From the bustling rail networks of Europe to the vast freight corridors of North America, locomotives remain the backbone of modern transportation. Today, we're exploring the fascinating variety of locomotives operating across the globe, each designed for specific purposes and adapted to unique challenges, whether powered by diesel, electricity, or emerging technologies. These remarkable machines continue to evolve and shape how we move people and goods around the world. Different types of locomotives that are in use today around the world. Locomotives have been the workhorses of transportation for nearly 2 centuries, and their evolution reflects humanity's continuous drive for innovation and efficiency. From the steam-powered giants of the Industrial Revolution to today's sleek electric high-speed trains, locomotives have transformed dramatically. What makes modern rail transport fascinating is the incredible diversity of locomotive types operating simultaneously across different regions, each serving specific needs and operating under unique conditions. Understanding these different types gives us insight into how geography, economics, and technology shape transportation infrastructure worldwide. Diesel locomotives. The versatile powerhouses, diesel locomotives, dominate rail operations in many parts of the world, particularly where electrification remains impractical or too expensive. The most common type is the diesel-electric locomotive, which represents an elegant engineering solution. Rather than mechanically connecting the diesel engine directly to the wheels, these locomotives use the diesel engine to generate electricity, which then powers electric traction motors attached to the wheels. This arrangement provides excellent control over power delivery and allows the locomotive to operate efficiently across a wide range of speeds. The diesel-electric design has proven remarkably successful for both freight and passenger operations. In North America, locomotives like the GE Evolution series and the EMDSD 70 series haul massive freight trains across thousands of miles. These modern diesel-electric units can produce over 4,400 horsepower and are designed for fuel efficiency and reduced emissions compared to older models. They feature sophisticated computer controls that optimize engine performance, manage wheel slip, and coordinate multiple locomotives working together in a consistent. Diesel hydraulic locomotives take a different approach, using hydraulic transmission to transfer power from the engine to the wheels. This design was particularly popular in Germany and parts of Europe during the mid-20th century. While less common today, diesel hydraulic locomotives offered smooth power delivery and were well suited for passenger services where ride comfort was important. For smaller operations, diesel mechanical locomotives still serve a purpose. These simpler machines use direct mechanical transmission, similar to a car, and are typically found in switching yards, industrial facilities, and short-line railroads where their lower cost and simpler maintenance requirements make them practical. Choices. Electric locomotives. Efficiency and speed. Electric locomotives represent the pinnacle of railway efficiency and performance. By drawing power from overhead catenary wires or electrified third rails, these locomotives avoid carrying heavy fuel supplies and can deliver sustained high power output. The absence of onboard fuel combustion means they produce no direct emissions, making them environmentally preferable in areas with clean electricity generation. The advantages of electric traction become most apparent in high-speed passenger rail operations. Japan's Shinkansen, which began operation in 1964, demonstrated that trains could compete with air travel for medium-distance journeys. Modern Shinkansen trains routinely operate at speeds exceeding 300 kilometers per hour, moving millions of passengers annually with remarkable safety records. The latest generation features advanced aerodynamics, active suspension systems, and regenerative braking that feeds electricity back into the power grid. France's TGV system pushed speed boundaries even further, with test runs exceeding 570 kilometers per hour. Commercial TGV services connect major French cities and extend into neighboring countries, demonstrating how high-speed rail can integrate regional transportation networks. The TGV's distinctive nose, design, and articulated train sets minimize air resistance and provide exceptional stability at high speeds. China has built the world's most extensive high-speed rail network in just 2 decades. The CRH and Fuxing series trains connect hundreds of cities across vast distances, with some routes spanning over 2,000 kilometers. These trains combine speed with capacity, carrying up to 1,200 passengers per train set and operating at frequencies that would be impossible with conventional rail technology. Electric locomotives also excel in heavy freight operations, particularly in mountainous terrain. Swiss and Austrian railways have long utilized powerful electric locomotives to haul freight through the Alps. These machines can deliver enormous tractive effort for climbing steep grades while using regenerative braking to recover energy on descent. India has made substantial investments in railway electrification, recognizing the long-term economic and environmental benefits of electric traction for both passenger and freight services. Steam locomotives. Living history. While steam locomotives no longer serve mainstream commercial purposes, they remain operational on heritage railways and tourist lines worldwide. These magnificent machines attract enthusiasts and tourists who appreciate the drama of steam power and the engineering achievements they represent. Organizations dedicated to preservation maintain and operate steam locomotives, often using them for special excursions and educational purposes. Heritage railways in the United Kingdom, the United States, and many other countries offer regular steam-hauled services, allowing new generations to experience this historic technology. Some mainline steam locomotives are certified for operation on modern railway networks, occasionally hauling special charter trains. These operations require dedicated teams of skilled engineers and firemen who maintain traditional knowledge and craftsmanship. Hybrid and alternative fuel locomotives. The railway industry is actively developing hybrid locomotives that combine different power sources for improved efficiency and reduced emissions. Battery electric hybrid locomotives store energy in large battery packs, allowing them to operate in areas without overhead electrification or to reduce diesel fuel consumption. These hybrids can charge their batteries using regenerative braking or from external charging stations, then use that stored energy to supplement or replace diesel power. Hydrogen fuel cell technology represents an exciting frontier for railway electrification without overhead wires. Several manufacturers have developed hydrogen-powered locomotives that use fuel cells to generate electricity for traction motors, emitting only water vapor. Germany has introduced hydrogen trains on regional passenger routes, demonstrating the viability of this technology for branch lines, where traditional electrification would be prohibitively expensive. Specialized locomotives for specific tasks. Railway operations require various specialized locomotives designed for particular tasks. Shunting locomotives, also called switchers or shunters, move individual rail cars around yards and industrial facilities. These compact, powerful machines need excellent visibility and precise control rather than high speed. Modern shunters increasingly use remote control systems, allowing operators to walk alongside and maintain clear views while maneuvering equipment. Mountain railways present unique engineering challenges that specialized locomotives address through rack and pinion systems. These locomotives engage a toothed rack rail mounted between the running rails, providing positive traction on grades too steep for conventional adhesion. Mountain railways operate in Switzerland, Austria, and various other mountainous regions, serving both tourist destinations and providing essential transportation links. Mining operations employ specialized locomotives designed for harsh environments. Surface mining locomotives haul enormous quantities of or in open-pit operations, while underground mining locomotives must operate in confined spaces with stringent safety requirements. These machines are built for durability and often feature enhanced safety systems. Industrial locomotives serve countless factories, ports, and steel mills worldwide. These workhorses may be diesel, electric, or battery-powered, chosen based on the specific requirements of their operating environment. Port operations increasingly favor zero-emission electric or battery locomotives to reduce air quality impacts. Magnetic levitation trains, or maglev, represent a fundamentally different approach to guided transportation. Rather than running on wheels, maglev trains float above the guideway, using magnetic forces, eliminating friction and enabling very high speeds. Japan and China operate commercial maglev systems, with China's Shanghai maglev reaching speeds of 430 km per hour in regular service. Regional variations in locomotive technology geography Infrastructure history and economic factors create distinct regional preferences in locomotive technology. North America relies heavily on diesel locomotives for freight operations, with the continent's vast distances and relatively flat terrain favoring powerful diesel-electric units. The limited passenger rail network outside the Northeast Corridor means electrification covers only a small portion of the network. Europe features extensive electrification across both passenger and freight networks. Decades of investment in overhead catenary systems enable electric locomotives to dominate mainline operations. The interconnected nature of European railways, with trains regularly crossing borders, has driven standardization and the development of multi-system locomotives that can operate under different voltage and frequency systems. Asia has witnessed explosive growth in railway electrification, particularly for high-speed passenger services. China, Japan, South Korea, and Taiwan have built comprehensive high-speed networks, while countries like India continue expanding. Electrification of conventional railways. The density of population and relatively high fuel costs make electric traction economically attractive. Australia presents unique challenges with extremely long distances and relatively sparse population. Heavy-haul diesel locomotives dominate freight operations, with some trains exceeding 2.5 kilometers in length. These locomotives must withstand harsh environmental conditions, from desert heat to tropical humidity. Modern technological advances. Contemporary locomotives incorporate sophisticated technology that would astonish earlier generations of railway engineers. Computer control systems manage every aspect of locomotive operation, from fuel injection timing to traction motor control. These systems continuously monitor hundreds of parameters, optimizing performance and detecting potential problems before they cause failures. Regenerative braking, once found only on electric locomotives, increasingly appears on hybrid and even conventional diesel locomotives. This technology converts the train's kinetic energy back into electricity during braking, either feeding it back to the power grid or storing it in batteries. The efficiency gains can be substantial, particularly in operations involving frequent stops or significant elevation changes. Modern locomotives feature energy-efficient designs that reduce fuel consumption and emissions. Improved diesel engines meet stringent emission standards while maintaining performance. Electric locomotives use advanced power electronics that minimize energy losses and improve power quality on the electrical grid. Remote operation capabilities are expanding, with some locomotives now operating with reduced crew or even autonomously in controlled environments. These systems use GPS, radio communications, and sophisticated software to navigate routes and respond to signals. While fully autonomous mainline operation remains limited, the technology continues advancing. Predictive maintenance systems use sensors and data analytics to monitor locomotive health continuously. By detecting where patterns and potential failures early, railways can schedule maintenance more efficiently and reduce unexpected breakdowns. This approach improves reliability while reducing maintenance costs. Future trends in locomotive technology. The railway industry continues evolving to meet changing transportation needs and environmental expectations. Electrification expansion remains a priority in many countries, driven by environmental benefits and long-term economic advantages. New electrification projects often incorporate renewable energy sources, further reducing the environmental impact of rail transportation. Battery technology improvements are making battery electric locomotives increasingly practical for routes where overhead electrification isn't feasible. As battery energy density increases and costs decrease, these locomotives will serve more applications, particularly on branch lines and in switching operations. Hydrogen fuel cells offer another pathway toward zero-emission rail operations. Continued development aims to reduce costs and improve the durability of fuel cell systems while expanding hydrogen production and distribution infrastructure. Automation. Technology will increasingly assist locomotive operators and may eventually enable fully autonomous operations in specific contexts. The transition will be gradual, with technology first supplementing human operators before potentially replacing them in controlled environments. Environmental sustainability drives much current development, with manufacturers focusing on reducing energy consumption, minimizing emissions, and using recyclable materials. Railways already represent one of the most energy-efficient forms of transportation, and ongoing improvements will strengthen this advantage. The locomotives operating today represent centuries of engineering, innovation, and adaptation to diverse global needs. From diesel-electric freight haulers crossing continents to electric high-speed trains connecting cities in hours. Each locomotive type serves specific purposes shaped by geography, economics, and technology. As the world addresses transportation and environmental challenges, locomotives will continue evolving, incorporating new technologies while building on the fundamental principles that have made rail transport indispensable to modern civilization.